Okay, hello everyone, it's Salar and we are in part 28 of our tutorial, a tutorial to writing a real-time operating system. In previous part, I talked about local variable in your programming language, okay? And how your compiler keep local variable in the memory. I said that your compiler will save your keeps your local variables in stack frame of your function, okay, and you will have your local variable in stack frame, and by returning from your function you will not have your local variable anymore, okay. But in this part we wanna get familiar with function return value. Okay, what is function return value? Assume that you have a function and the return value of your function is integer number, okay, 4 byte is a 4-byte number. And for example, assume that you return a value from your function, okay. How your compiler return a value from your function? Okay, we want to get familiar with this subject and this topic. Okay, return value. How your compiler return a value, return the return value to the color function. Okay, what is color function? Let's describe that with this example. Assume I have a main function and I want to call this function in the main function. The main function in this example is a color function, okay? And your compiler and your processor will return value from this function to main function, okay? So how your compiler return a value to the color function? There are two ways to returning a value from a function. First, with register R0 to R3, just like arguments, okay? If the return value is smaller than or equal, forward, just like arguments, okay? Your compiler will use these registers to return the value to the color function, okay? But if the return value is greater than forward, your compiler will use a stack frame to return the values from your function, okay? I will say in next slides how you can have a return value that is greater than forward, okay? But first, let's talk about this example. Assume that I have my main function and I have this function. In this function, I want to return this value 50 to the main function and put in this variable, okay? So how your compiler do this work? First, let's see this example, but it's not important to see the example. Let's see the assembly instructions of this function, okay? This is assembly implementation of this function, okay? First, just like other functions with these instructions, your compiler will create your stack frame, okay? And to return this value, your compiler will use these instructions, okay? To return value, first put this value 50 to register R3, and after that put the register R3 in register R0. So you will have your return value in register R0, okay? You will have your return value in register R0. And in your main function, okay, in your main function, here is implementation of this function. With these instructions, your compiler and processor will create your stack frame. Here is main function stack frame, okay? You have your link register and R7 in your stack frame, and how your compiler create this number, as I said, with this formula, plus 8 multiplied by k. If the number of these registers is an even number, you will have 0 plus 8 multiplied by 1 equal to 8, okay? For white 4 byte for your variable, for your local variable, and 4 byte is unused. Okay, like previous part. Okay, after that, branch to your function, and after returning from your function, put store r0 to this address. Okay, you want to put the return value to your local variable. As I said, you have your return value 50 in register r0, and your compiler put this value in this address r7 plus 4, r7 plus 0 plus 4 plus 8 and plus 12. Okay, put the value of r0 in your local variable, so you will have the return value in this variable. Okay, in your stack frame. But what will happen if the return value is greater than forward? Okay, how can I have a return value, return type that is greater than forward? Okay, I have an example here. For example, assume that you have a user defined type, just like here. str is a user defined type in C programming, and this is sometimes known as composite type. Okay, I have an struct that the name of my structure is my struct, and the size of my struct is 6 word. Okay, so this type, the length and the size of this type is 6 word. Okay, with type def you can define a new type in your program. Okay, and in my function I have this type. Okay, I have a variable that the type of my variable is str, so the size of this variable is 6 word. Okay, the value of this variable, that is local variable, is here. Word 0 is 10, word 1 is 11, and word 5 is 15. Okay, and I want to return this value to main function. Okay, my main function, call this function, and I want to return this value to main function. The size of my return value is greater than forward. Okay, let's talk about that with this example. Let's see the assembly instruction of this code in terminal, and let's see compile this code and see the object code of this example in terminal. Okay, as you can see, here is my code. I have a user defined type in my code, and the length and the size of my type, this type is 6 word. Okay, and I have a local variable with this type, and the return value and return type of my function is this user defined type. Okay, so my function will return 6 word by returning from this function. Okay, my processor will return 6 word by returning from this function. Let's compile and see the object code of this example. Okay. Make the project and see the object file of my code. As you can see, here is my main function, and here is my function. Okay. Sorry. Here is the assembly implementation and assembly code of my main function, and let's inspect these instructions more in this slides. Okay, so as you can see, the assembly code of my main function is here. Just like other functions, you will have some instruction to create your stack frame, and As you can see, your compiler put the value of R7 to register R0. First value of R7 to R3, and after that put the value of R3 to register R0. Okay, you will have, what is R7? What is R7? Main function stack frame limit address. Okay, the limit address of main function stack frame. So I have the value of register R7 in register R0 and branch to function. Okay, and branch to function. Let's to see the stack frame of main function in this slide. Like other functions, your function first put some registers in your stack frame. For example, here link register and R7, and create your stack frame. The size of this part is 24, just like before, 0 or 4 plus 8 multiplied by k, because the number of this register is an even number. To register 0 plus 8 multiplied by 3 is 24. Okay, so here, sorry, and after that put the value of your stack pointer to register R7. Okay, now my register R7 in main function, and point to this address. Here is main function stack frame, stack limit address of my main stack frame of my main function. Okay, so you will have your return value in your stack frame of your color function. Okay, main is a color function. Okay, and you will have the value of this return value in your main stack frame. Okay, after returning from this function, you will have the return value in your stack frame. Okay, but before to jump into your function, your processor put this address in register R0. Okay, put this address in register R0 in this instruction. So your compiler and your processor will jump to your function, and let's to see the assembly code of my function. Okay, here is my function, and here is assembly implementation of my function. Okay, but before to talk about all of these instructions and comments, I should say these instructions implement this line of your code. Okay, return my str. Your compiler implement this line with these instructions. Okay, let's to inspect all of these instructions with these slides. Okay, but before that, let's to see the complete assembly code of this function here. Okay, as you can see, just like other function, first create your stack frame. Okay, by these instructions, as I said, make stack frame in first instructions. After that, I have an instruction. I will talk about that in I will talk about this instruction in next slide. Okay, this instruction, and after that initialize your local variable with these instructions. Okay, with these instructions, and I commented these instructions here. Okay, initialize my str and put the value of your local variable in your stack frame. Okay, and after that with these instructions implement this line of your code, this line of your code. Okay, this line of your code. Okay, But as you can see, first push these registers to your stack frame and calculate the limit address of your stack frame. The value is 36. Okay, just like before, because the number of these registers are even. 4 plus 8 multiplied by 4 is 36. 4 byte for padding and 6 byte for local variable and two other 4 byte. One of 4 byte is unused and one of them 4 register are 0. Okay, register are 0. As I said, register R0 have R7 main stack frame limit address. Okay, in this part of your stack frame you will have the main stack frame limit address R7 of main. Okay, that is in register R0. Okay, with this instruction your compiler put register R0 in this address R7 plus 4. Okay, put the register R0 main R7 to this cell in your stack frame. Okay, but let's talk about these instructions. Okay, in this slide. So here is function stack frame and here is main function stack frame. First, in this instruction, your compiler puts a value from this address R7 plus 4. R7 point to this address plus 0 plus 4. Write this value, the stack frame limit address of my main function to register R3, and after that put register R3, register R5. So register R5 now point to this address. Okay, after that R7 plus 8, put the value of R7 plus 8 in R4. Okay, plus 8, and R4 now point to this address. Okay, after that run this instruction, load multiple and increase after with write back. I think I forgot to talk about this exclamation mark in load and store multiple. Okay, when you have this exclamation mark in load or store multiple, increase after or decrease before, your processor will increase and decrease the value of this register by each load and store. Okay, if you don't have this exclamation mark, your processor will not change the value of this register. But if you have, for example, here this exclamation mark in front of your register, your processor will change the value of this register by each load and store. Okay, so when your processor run this instruction, your processor will write from this address to register R0. Okay, and from R4 plus 4 to register R1, and write this value in register R2 and write this value in register R3. Okay, and because of this exclamation mark, change the value of R4 to point to this address. Okay, after this instruction you will have this value in register R0, this value 11 to register R1, this value to register R2, and this value to register R3. Okay, And after that, run this instruction. Okay, write from this register to this address, write from register R0 to this address, write from register R1 to this address, from here to here, and write from here to here, and change the value of R5 to this address, okay, because of this exclamation mark. And after that, with this instruction, write another time this value to register R0 and this value to register R1, and with this instruction write this value to this address and this value to this address. So you will have your return values in your color function stack frame. Okay, you will have 10 here, 11 here, 12, 13, 14, and 15. And by some instructions, after that, by some instructions, return from your function. Okay, return from your function. And in this way, your compiler will return a return type that is greater than forward. Okay, but let's to see this example. For example, assume that for example, assume that you have a local variable and you want to put the return value from your function in this variable, and var, for example, it's 1 plus plus, and var dot, for example, is 4 plus plus. Okay, let's just save that and make my project. As you can see, the size of stack frame without this register is 24 for my main function, but in this time I have a local variable in my function. Let's to see, let's to compile the code and see the result. Make object, make object. Another time in my main function this value is 24. Okay, because your function shares this part of your stack frame in main function between your local variable and your return value. Okay, so as you can see, first put this this register R0, branch to function and return from your function. Okay, and return from your function. So when you return from your function, you will have your structure cells here. S0 in R7 plus 0, 4, 8, 12, 16, and 20. Okay, so to implement this line, S0 plus plus. S0 means R7 plus 0. Okay, after return from your function, load the value of S0 to register R3, S0 plus plus, and after that store another time in a stack frame, and for S4 plus plus, S4 plus plus, R7 plus 16, R7 plus 16, S4 is R7, this address plus 16. Okay, so your compiler shared the return value of this function and this local variable in a stack frame. Okay, in this example. So when you want to return a value from your function, if the return value is smaller than or equal forward, your compiler and processor use these registers, or if the return value is greater than forward, is a composite type, like this is a composite type, your processor will use your stack frame in your memory to return the value to the color function. Okay, enough for today, enough for this part. Thank you very much to see me, and see you soon in the next part. Thank you very much.